Night! I'm making this video at night right now, so I'm saying math night. But you might be watching it in the morning, so math morning to you. So these are some videos of crossovers, and I thought it was a good way to intro today's lesson, which is solving proportions with cross products. See what I did there? Crossover, cross products. Okay, moving on. So let me tell you about cross products. This definition says, in a proportion, a cross product is the product of the numerator of one ratio and the denominator of the other ratio. The following property involving cross products can be used to solve proportions. What does that mean? So it says the product of the numerator of one ratio, that's the top of the fraction, and the denominator of the other ratio, the denominator is the bottom, and it's the product of those two things. So in this picture, they take this 3 and the 8, the numerator of one and the denominator of the other fraction, and they multiply it together, and the same with this denominator and that numerator. Right, so 3 times 8 is 24, 4 times 6 is 24, and you can use that fact to solve these. But it looks crazy. A lot of textbooks do it like this, but let me show you a way that I think makes it look much easier. So here's some examples. Cross multiply. They said take the numerator of one, so that's 3k, and multiply it times the denominator of the other one. So 3k times 3, and that equals, when you multiply the denominator of this one and the numerator of the other one. So you make an x, right? You cross. And then this side will be 27 times 2. So you're crossing, and it's a product, so you're multiplying each one. Alright, then you solve these. 3k times 3, you can multiply the 3's together, and that equals 9. And you keep the k. Over here, 27 times 2, that is 54. After that, you have an equation, and you just solve it like we did in the previous unit. So this is 9k, which means 9 multiplied by k. You want to do the inverse operation, so that is divide. So I divide each side by 9. This cancels. I'm left with k. And 54 divided by 9 equals 6. So my answer right there is 6. So that is cross product, and you can use that to solve for variables. So this one, the next one gets a little bit trickier. I'll start off with multiplying 7 times x. That wasn't the tricky part, if you're wondering. So 7 times x will just be 7x. And that equals 3 times 2x plus 5. It's not just 3 times 2x. If you remember from my earlier videos, GEMDAS or GEMDAS begins with G. That's for grouping symbols. The top of a fraction is a grouping symbol. So it's really 3 times 2x and then 3 times 5. So you write that with a parenthesis down here. 3 times 2x plus 5. After you do this, we want to distribute and then solve for x. So when I distribute, I do 3 times 2x. That will be 6x. And then I do 3 times 5, which is 15. It was plus here, so I put the plus right there. And that equals 7x. Now I need to solve for x. So let me combine the like terms. I have an x right here and an x right there. I will subtract 6x from both sides, minus 6x. I can draw my line to keep everything organized. Those cancel. 7x minus 6x is 1x. Or I can just write x, and then I bring down the 15. X equals 15. That's my answer right there. Bam! Alright. Now this next one is even a little bit crazier. Before I show you, I'm just going to delete all this stuff to give me some more space. So over here, you might notice this one has a negative sign. Negative signs tend to freak people out. But don't worry, there's an easy solution. So if you see a fraction like this, maybe negative 2 over 3, right? And the negative sign's over here, a big negative sign. You can do two things. You can leave it out here, or you could put it on the top. So negative 2 over 3. Actually, I lied. You can do three things. Or you could put it on the bottom. 2 over negative 3. I think it's the easiest if you just keep it on the top, right? So this is the same as negative 2 over 3. That's going to simplify your life when you're trying to solve these problems. So there's a negative out here, right? I don't want that there. I'll put it in front of the 2. Make it a little bit easier for me. Alright, so now I'll do this one, and let me get these out of the way. Don't look at those. I'll draw a little line over here. Now we need to cross multiply. So I take 6, multiply it times w minus 10. These fraction bars are grouping symbols, so I like to put parentheses around these first, just to make sure when I multiply I don't forget them. So 6 times w minus 10. Give me a little space. 6 times w minus 10. And that equals, over here, 4 plus 2w times negative 2. I'll write the negative 2 first, and then I'll write 4 plus 2w. Alright, these are the same thing. 6 right there, w minus 10, yep, negative 2, 4 plus 2w. Perfect. So now we have this, and we have to distribute to simplify this equation. So I'll start with this one. 6 times w. Well, that equals 6w. Then I do 6 times negative 10. That equals negative 60. That equals 2 times 4. Sorry, negative 2 times 4, which is negative 8. And then negative 2 times 2w, which will be negative 4w. So now I have this simplified equation. I need to combine my like terms so that I can solve it. So I'll draw a line down the middle. What should I do first? I've got a 6w over here, a negative 4w over here. I like changing negatives to positive, so I'll do a plus 4w right there and a plus 4w over here. Alright, that cancels. 6w plus 4w, that equals 10w, and then I bring down the minus 60, and that equals negative 8. Now I need to get rid of this negative 60, so I have the w by itself. So I do plus 60, and I do plus 60. Draw this line. Alright, that cancels, and I'm left with 10w on this side. Over here, negative 8 plus 60, that's going to be negative 52. Now to get the w by itself, I divide by 10. I divide this by 10. Alright, draw this line again. These cancel, I'm left with w over here, and that equals negative 52 over 10. Alright, so I'll even write that, negative 52 over 10. But this can be simplified. Each of these are even numbers, so I'm going to divide the numerator and the denominator by 2. So negative 52 divided by 2, that will be negative, what will that be? Negative 26, and 10 divided by 2 is 5. So my final answer, negative 26 divided by 5. Alright, now I want you to pause this video, try these two problems. Alright, here we go. So over here, cross multiply. Remember, I like to put the parentheses around the top of or bottom of the fraction when there's more than one term. So we have d plus 1 times 7. I'll put the 7 first. 7 times d plus 1. Over here, 4 times 3d plus 6. That equals 4 times 3d plus 6. And if you're thinking, hey, how come that first one, why didn't he put the d plus 1 first and then the 7? The property, if you remember, that allows me to do that is the commutative property. It says you can switch the order of the things you are multiplying. Alright, so now I need to simplify this bad boy. First thing, distribute. 7 plus d. 7d. And then I'll do 7 times 1. That is 7, right? And there's a plus sign there, so I put a plus sign there. Now this side, 4 times 3d. That will be 12d. 4 times 3 is 12, and I just put the d there. And then I do 4 times 6. That's 24. A positive times a positive is a positive. Perfect. So now I've got my equation, and I need to simplify. So I have 7d over here, 12d over here. I'll subtract 7d from this side, and I'll subtract 7d from this side to combine those terms. So this cancels. I'm left with 7 on this side. Over here, 12d minus 7d, that is 5d. And then I have plus 24. I want to isolate the d, so the next step will be subtracting 24 from both sides. Minus 24. Those cancel. This side I have 5d. Over here, let's see, 7 minus 24. That will be negative 17. My last step, I have 5d. I want d by itself. I divide by 5. Why do I divide? 5d, that means 5 multiplied by d. And those are inverse operations, multiply and divide. So I divide on this side too. That cancels. I'm left with d equals negative 17 over 5. That's my final answer right there. Oop, can you see that? I'm changing my pen color. Alright, negative 17 over 5 equals d. Perfect. Let me go up to this next one. Draw my little squiggly line. Same thing as the last one. I like parentheses. I put them right there. Bam, boom. Now I multiply c minus 8 times 11. I'll put the 11 first. I'm allowed to do that because of the commutative property. Then I have c minus 8. That equals negative 2 multiplied by 11 minus 4c. Perfect. So now, just like the last one, I need to distribute 11 times c. That equals 11c. 11 times negative 8. That's going to be negative 88. Alright, so this side is good. Now I need to do over here. Negative 2 times 11. That equals negative 22. Negative 2 times negative 4c. Well, negative times a negative, that's going to be a positive. 2 times 4, that's 8. And then I keep the c. Perfect. So now I need to combine the like terms. So I have a c right here and a c right there. I could do minus 11c or I could do minus 8c. I'll do minus 8c because I want to keep my numbers positive. Let me draw this line. Minus 8c over here as well. So these cancel. 11 minus 8, that's 3, and then I have the c. Right, see, so 11 minus 8, that's positive. If I had done minus 11c, I would have had to do minus 11c over here, and I would have had a negative answer. I don't like that. I like positive numbers. Alright, so I'll copy this 88, and that equals, what's left over here is negative 22. Okay, cool. So now, what do I have to do? I need to do plus 88. Because that cancels the negative 88. If I do it over on this side, I need to do it on this side. Alright, so I bring down the 3c. Oh, the 3, that's a... Here, let me... what did I do? Don't worry, I fixed it. Alright, so I bring down the 3c. Let me write a C this time. Negative 22 plus 88, that happens to equal 66. My last thing that I want to do is get the C by itself, so I divide by 3. I'm dividing by 3 because this is 3 multiplied by C. I divide this side by 3. Those cancel. I'm left with C equals 66 divided by 3 is 22. Bam. Solved. We did it. Beautiful. Moving on. Alright, let's do some real world examples now. So these are scale drawings, right? These are small drawings that represent things in real life. And the scale is normally written somewhere on the corner. This one says the scale is 1 inch to 12 feet. So in this little picture, every 1 inch is really 12 feet in the real life house. Alright, so you can set up proportions to solve these problems. What I like to do, let me see, this is scale, so I might write scale drawing, SD, and then real life. Alright, and it says the scale, that is 1 inch, in real life is 12 feet. So let's say if I lived in this house and I wanted to find out, well, how big is this garage? Alright, if I measured this thing right here, and let's say this was 4 inches, right? In this proportion on the scale drawing, this line was 4 inches. So how long is the real life part? Well, I can find out. I just cross multiply and solve for x. So I can do 1 inch times x, that's 1 inch times x. Over here, 12 feet times 4 inches, I have 12 feet times 4 inches. Now I want to divide, cancel some things out. So if I divide this side by 1 inch, 1 inch, and I divide this side by 1 inch. Alright, what cancels around here? What cancels? So the 1 inch cancels, I'm left with just x. Over here, that inch and that inch cancels. So on top I'm left with 12 feet times 4. That's going to be 48 feet. And the bottom is just 1. So if this was really my house, my garage would be 48 feet long. Alright, so let's try this with a real problem. So this is Ohio. This is a state in the Midwest. This is a Great Lake up here. Cleveland, that's where LeBron plays. Cincinnati, they have the Bengals. What you need to do is get a ruler. You can ask me where they are. They might be in that metal cabinet. They might be in the closet in the back. They might be on my desk. Just ask me. I'll give you a ruler. And you need to measure the distance from Cincinnati to Cleveland. Cincinnati to Cleveland. If you don't know about Columbus, let me tell you a little bit about Columbus too. This is a city, it's the capital, and the college, Ohio State, as a big college there, is located in Columbus. They have a phenomenal marching band. So I'm going to play you a quick video of the Ohio State marching band doing a tribute to Michael Jackson. Pretty cool, right? So if you want to go to a big college where they have a big football team and a marching band, Ohio State, that could be a choice for you. Anyway, did you get a ruler yet? If you didn't, get one and measure the distance from Cincinnati to Cleveland. Alright, so I measured it. I got 4 centimeters. If it's not 4 centimeters, my bad. I tried my best. But we'll use 4 centimeters as a measurement in this example. So I want to set up a proportion, right? Here's my scale right here. So this map is 1 centimeter. In real life would be 85 kilometers. So let me write map to real life is 1 centimeter. The map is 1 centimeter. Real life is 85 kilometers. All right. And so what this is going to equal, this 4 centimeters, that's the map. So that goes in the same line as the map, 4 centimeters. And I want to find out how many kilometers the real life is, how many, the distance between Cincinnati and Cleveland in kilometers. So now I need to cross multiply and solve for x. All right, I draw my arrows. 1 centimeter times x, I have 1 centimeter times x. That equals 85 kilometers times 4 centimeters. All right, and you could simplify this in different ways. You could do 85 times 4 first. That's perfectly okay. And let me actually do that. So 85 times 4 is 340. And then I have kilometer and centimeter, right? I'm just going to write both of those. Kilometer, centimeter, right? Because I didn't cancel anything out yet. Over here, I still have 1 centimeter times x. So to get x by itself, I divide by 1 centimeter. That whole thing's canceled. I divide this by 1 centimeter. So now this side I'm left with x. Over here, these centimeters cancel. I'm left with 340 kilometers over 1. Right? That's the same as 340 kilometers. So bam, there it is. From Cincinnati to Cleveland, 340 kilometers. Alright, we got this problem right here. It says, the ship model kits sold at a hobby store have a scale of 1 feet to 60 feet. A completed model of the Queen Elizabeth II is 1.6 feet long. Estimate the actual length of the Queen Elizabeth II, or the second. So this says the ship model, that's like a tiny boat, is sold at a hobby store, where you buy collectible things. And the scale is 1 feet to 600 feet. A completed model of the Queen Elizabeth II, that's a fancy, famous boat, is 1.6 feet long. Estimate the actual length of the Queen Elizabeth II. I want you to pause this video, try it by yourself. Alright, so here we go. And if you didn't pause this video and you didn't try this by yourself, you really should. That's how you get the growth mindset. That's how your brain gets better, if you're really trying to do these problems. Alright, so I wrote a proportion. Ship model, real life. The ship model is 1 feet. The real life is 600 feet. I got that right from there. Then it said a completed model of the Queen Elizabeth is 1.6 feet long. So the model, the ship model, right, is 1.6 feet. Estimate the actual length, right? The actual length, that's real life. So that's why I put the x there. Next I cross multiplied. 1 feet times x, 1 feet x. Then I did 600 feet times 1.6 feet. Bam, right there. After that I simplified. 1 feet times x is 1 feet x. 1.6 times 600 is 960. Feet times feet is feet squared. Then I isolated x by dividing by 1 foot on both sides. I did that. And a little tricky part, right? If you have feet squared divided by feet, one of the feet cancel up here. And I'm left with just feet. So x equals 960 feet. If these unit things are really confusing you, you can try it without the units And at the end, just know your answer is going to be in feet, no matter what. All right, so if it's confusing, you can just put feet at the end. All right, that's it. We're done for the day. Good luck with the mastery check. Good luck with the packet. You can do it. If you're thinking, hey, this is the first video without a cat, whatever. Durkis, out.